Salomon's truck gets 24 miles per gallon when driven at a speed of 40 miles per hour with no load. When there is no load, the speed was 40 miles and the mileage comes out to be 24 miles per hour. His truck's gas mileage decreases by 1 miles per gallon for each 500 pounds of added load, and it decreases by 1/2 miles per gallon for each 10 miles per hour of increased speed over 40 miles per hour. Which of the following formula is the formula of the gas mileage of Salomon's truck when its speed is S miles per hour? S is greater than equal to 40 and it has load of L pounds. Now there is a question. It gives that when there is no load, right? When there is no load, if there is no load, so how much is the mileage? At which speed? At no load, the condition at no load is that the speed is 40 miles and the mileage is at a speed of 40 miles per hour, the mileage comes out to be 24 miles per gallon, right? This is the ideal condition when there is no load. Now there is a load. How much is a load? That is L pounds. And when there is a load, according to question, the mileage decreases by 1 miles for each 500 pounds of added load. When there is a load of 500 pounds, the mileage got decreased by 1 miles per gallon. 1 mile per gallon, it got decreased. The mileage decreases. So if there is a load of 500 pounds, it got decreased by 1 miles per gallon. If there is a load of 1 pound, added the load of 1 pound unitary approach, then the mileage should decrease by 1/500 miles per gallon. This should be the decrease in the mileage, right? And there is load of how much? This is for one pound decreases 1/500. Had the load be L pounds, if the load is L pounds, so can we say that if the load is L pounds, it will be L upon 500 miles per gallon. This should be the decrease. This should be the decrease if the load is L pounds. No load, the mileage was 24. When there is a load of L pounds, the decrease in the mileage will be L minus 500. So we can write here 24 was the original mileage. When the load was L pounds, mileage decreased by L upon 500. This is the decrease due to the L pounds of the load which is there. Okay, so this part is done. Now there is a speed. According to question, what does it say? If there is a speed of increase of 10 miles per hour, when the speed was 40 miles per hour, the mileage was 24. Now the speed is increased, right? What about speed? With each 10 miles increase, 10 mile per hour, it increases. If the speed increases, the mileage decreases by 1/2 miles per gallon. It got decreased. Got this? Now, if speed, that's the second criteria, increase by 10 miles, mileage decreases by 1/2. So what will be if the speed increases by 1 miles per hour, 1 mile per hour increase? Can we say it will be 1/20 miles per gallon decrease? It will be a decrease of 1/20 miles per gallon. Now, how much is a speed increases? Above 40, 40 is the speed which is given to you, right? How much above 40 is S? That means how much it got increased. It will be increased, will be above 40, will be S minus 40. Why? Because 40 was the usual speed. It got increased. How much it got increased? The current speed is S miles per hour. That means it got increased above 40 by S minus 40 miles per hour. So 1 mile per hour increase. Due to this, the decrease is 1/20. So S minus 40 miles per hour increase in the speed leads to how much decrease in the mileage? That is S minus 40/20 miles per gallon. Miles per gallon decrease. It will get decreased. So due to the speed, how much the mileage gets decreased? That is S minus 40/20. Original was 24. Due to the load, the mileage decreases by L by 500. due to speed, the mileage gets decreased by S minus 40 over 20. That is the effective mileage or the new mileage formula which was required in the question. Now, let's solve this. So 24 minus L upon 500, open the bracket, this is S minus 40 upon 20. So S, this can be written as S over 20, open the bracket, minus minus plus 40 over 20, right? 20 divides S also, 20 divides 40 as well. This would be the case here. So that's our answer. 40, 0, 0 gets cancelled. 2's are 24 plus 2, that is 26, minus L by 500, L by 500, minus S by 20. That's the effective mileage according to the load and according to the increase in the speed. That is option C being the correct here.